Hi everyone, I want to welcome you to this video where we're going to give a brief introduction to polynomials and polynomial functions. So polynomial is an algebraic expression that looks like this. And in regard to polynomials, there's a little vocabulary we want to be familiar with, so you should know these expressions. The terms of a polynomial are the things that are separated by pluses and minuses. So the negative 4x to the fifth, that's a term. And the negative 7x to the fourth, that's a term. And 3x cubed, that's a term. So these are the terms of the polynomial. We call this first term the leading term, and we call the last term that doesn't have an x in it, that's the constant term. And the coefficients of a polynomial, those are the numbers in front of the term. So the coefficient of the leading term would be negative 4, and the coefficient of the next term here would be negative 7, and the coefficient of this term would be 3, and so on. Okay, the leading coefficient is negative 4. That's the coefficient of the leading term. The degree of a polynomial, well, each of the terms has a degree. The degree is the power of the exponent. So the degree of this term is 5. The degree of this term is 4. The degree of this term is 3. If you come down here, you could think of this as 24x to the 0. So the constant term has degree 0. But when we talk about the degree of a polynomial, we mean the highest occurring exponent. So the degree here would be 5 in this case. Okay? The leading coefficient was negative 4. The coefficients, we talked about that. And then the other thing you want to do with polynomials is always list them in descending order. That means that you want your exponents to have the leading term, the highest exponent out front, and then put them so that the exponents go down. That's what we mean by descending order. All right, so let's move on and talk about the graph of a polynomial, just so you have a little visual to go with it. Here's a couple examples of polynomials that provided some graphs for, and you can see this first one here is p of x equals x cubed minus 4x, and this is the other one that I have listed there. P of x equals x to the fourth minus 4x squared. And just a couple things to notice about a polynomial is that number one, polynomials are continuous. You can always graph a polynomial without lifting your pencil. So notice that you never have to lift up your pencil to complete the graph there, and that's related to the domain of a polynomial. The domain of a polynomial is all real numbers. You can plug any number into a polynomial. Sometimes we use this notation for all real numbers. Or you could say from minus infinity to infinity. There are little arrows on these that my graphing calculator didn't put on there, but basically just continues on forever. So if I can plug any number I want into a polynomial, right? When you think about this, the only domain restrictions we know at this stage in our algebra is you can't divide by 0. And you can't take square roots of negative numbers. And polynomials don't have any square roots in them, and they don't have any division by a variable where there'd be a hole or a big chasm in the graph there. Okay? So the graphs of polynomials, they're continuous. And another thing to notice is that they're smooth. There's no sharp edges on a polynomial. They always they have nice curves and make nice turns. There's no real sharp, even though on your calculator it looks like there's a little bit of a point right down here. If you were to zoom in on that, you'd notice that it's real smooth right there. Okay, it still makes a nice curve. Okay, so let's move on from that then, and just let's finish up this introduction to polynomials by just reviewing how to add and subtract polynomials. And you remember that to add or subtract polynomials, all you do is just simply combine like terms. So adding polynomials is very straightforward. So I'm just going to do an example of subtraction. The only thing with subtraction, you just have to remember to distribute the minus sign to each of the terms. So write this out as negative 7x squared plus 5x plus 6, and you have to subtract 4x squared and subtract 3x and subtract the minus 2, that would make a plus 2. And then you see that I have a couple x squared terms here. If I combine those together, I'd get a negative 11x squared. And then I've got a couple x terms. I got a 5x and a negative 3x. So that'll give me 2x. And then I've got the 6 and the 2. That makes 8. Okay.